Okay, so lecture number 9. We've addressed already some issues connected with the ontology of classification, particularly in connection with what I was calling partitions. So you'll remember we were talking about the Beatles being an aggregate of 4 people. The Beatles is not an aggregate of 4 trillion cells, even though the 4 people who make up the Beatles are materially identical to a certain collection of 4 trillion cells. And that's because we are partitioning reality at the level of people when we talk about the Beatles, and at the level of cellular biological structures when we talk about the cells. And they are partitions which have different levels of granularity. So we've talked about these kinds of issues earlier on. Today I want to try to develop a more robust theory of granular partitions and connect granular partitions to phenomena of classification in general and to the issue of measurement. So I want to present a theory of measurement. Now, there is color in reality. Many philosophers disagree with that statement. I disagree with them, and I'm right. So the world has color in it, but the world doesn't necessarily have redness or greenness or blueness in it, because, as Plato would say, there are no joints in reality which separate redness or greenness or blueness, because they are connected together as part of a continuum. So if we talk about redness as being something different from greenness, then we have to be very careful to specify what we're doing. And what we're doing is basically we're making a partition. We have a continuum, and we partition it into red, orange, yellow, green, blue, indigo, violet, and so forth, because we find it convenient to describe colors using terms like red, green, blue, and because that captures many of the phenomena which we're interested in. And it does justice to the fact that there is color in reality without making the mistake of supposing that there is redness in reality. Now, there is redness in reality, but the way in which there is redness in reality is different from the way in which there is color in reality. And I think this will become clear over and over again in the course of what I say, but I will make it very clear once and for all, and anticipate, therefore, everything I'm going to say later. There is length in reality, but there are no centimeters in reality, in the sense in which there are lengths in reality. In order for there to be centimeters in reality, certain things had to happen in France. And those things did happen, in virtue of which we talk about centimeters. Now, some people would say that centimeters are socially constructed. I think there is a small grain of truth in speaking like that, but it's only a very small grain of truth, so I won't speak like that. All right. Something similar applies also in other kinds of continua. So in medicine, we talk about hypertension, and we talk about some people who suffer from mild, some people who suffer from moderate hypertension, and so forth. Now, hypertension really does exist in reality, but it exists in reality in the same sort of way that centimeter exists in reality, because doctors found it convenient to create a threshold between those people whose blood pressure is normal and those people whose blood pressure is elevated. And it can be elevated a lot, and then they suffer from severe hypertension, or it can be elevated only somewhat, and then they suffer from moderate or mild hypertension. And there is a threshold which is determined by fiat. There is no sudden jump between those people without hypertension and those people with hypertension. Those people with hypertension have a higher risk for certain kinds of other symptoms, and hypertension measured is a good marker for diagnosis purposes. That's why people made that fiat distinction. That's why we talk about hypertension. It's useful to talk about hypertension because of those facts about people whose measurement of blood pressure is above a certain level. But that hypertension itself is an artifact of our deciding upon that threshold. Now, Poland is a bit similar. There would be no Poland unless certain people in, I don't know, the 13th or the 14th century drew lines on a map or on the ground and started to treat the portion of the surface of the planet on one side of those lines differently from the way in which they treated the portion of the surface of the planet on the other side of the line. So we're dealing again with threshold phenomena. The thresholds are created by fiat. Now, it could be that the thresholds correspond to major rivers, so that it was actually very difficult to cross between place A and place B, and so the people on the side of A, on one side of the river, didn't intermarry with the people on the other side of the river as often as the people on the one side intermarried with people further away from the river. And so gradually the people on the two sides of the river became different, and they started to hate each other, or to see each other as different, the other. And so Poland came into existence. Now, the story of how Poland came into existence and the story about how all of these countries came into existence is always very complicated. But at the moment, Poland is an area on the surface of the planet which is surrounded by a fiat boundary. And it's fiat all the way around, including at the coastline. All right. So, and the same goes for things like census tracts and parish boundaries. So there are many boundaries along the surface of the planet which are created by fiat, in virtue of which geospatial, geopolitical, geo-administrative entities exist. These entities have histories. The boundaries of the entities can change. The boundaries of Poland changed. There was a long period of time during which Poland, I have to be very careful now, Poland as a creature of fiat boundaries on maps did not exist. The Polish people believed that Poland existed in their hearts. That's an ambiguous sentence. But as far as geopolitical reality was concerned, Poland did not exist. All right. I'm not sure what this is doing here. So, yes, I do know what this is. So, the world knows color. The world knows red. Sorry, the world knows red. We know Poland. So both the world and we know of redness. The world doesn't know Poland, at least not during that particular period when it didn't exist. Perhaps never. So what we know and what the world knows they overlap. And of course, the amount that we know might grow if we're lucky, but it will never exhaust everything that the world knows. And then there is what we think we know. And that really, so God knows exactly which is in which box at any given time, and that for the moment I'm playing the role of God. So I bin things. Now there are things that we know and that we really do know, and then there are things that we think we know but we really don't know. And that's why science needs to be corrected. So now, why is the issue of color and redness so important? Why do we have words like red and green and blue, or the RGB code system for more finer granularities of color, and perhaps even more granular systems for designating colors than RGB? We have all of those things because when we use language, we have to discretize. When we use most media of communication, we have to discretize. So it's very hard to communicate continuum rich phenomena using language or using the standard artifacts of diagrams, cartoons, and so forth. Even photography has some kind of granularity. A digital photograph may have a very, very fine granularity, but it still has some kind of granularity. And so there is no artifact of representation, whether linguistic or pictorial or video, that can capture continuum density rich targets. We can have samples, so we can lift up this bottle of water and say this is reality which has continuum many parts, or which has infinitely many parts. But we can't represent all of those parts for the trivial reason that we have only a finite amount of representational structure at our disposal, both on the side of artifacts like language and images, and also on the side of our brains. So our brains can't capture continuum complexity. We always have to discretize. And when we discretize, then I have to be very careful here. In fact, I will be careful by presenting a view which is obviously wrong. When we know reality, reality itself is a continuum. So when we know reality, since we can't know a continuum, it must follow that reality is not a continuum. Therefore, reality is discrete. That's a bad argument. That's the world's worst argument. And if you Google the world's worst argument, you'll find a whole paper giving a family of such arguments. So we can't know reality except insofar as it conforms to our perceptual faculties. Therefore, we can only know sense data. We can't know things in themselves. That's another example of the world's worst argument. Now, a good argument would go something like this. The world is full of continua. In order to know the world, we have to use discrete representational artifacts. But these discrete representational artifacts are like telescopes or microscopes. In other words, they're transparent. They tell us what the world is like. In some circumstances, it's important that we're aware of the discretization process. But we should not suppose that the discretization process is a falsification process. That chair over there really is red. It's a dark red. That's really true. I needed to use the discrete term red, but that doesn't mean that what I said is false. Similarly, this box is 4 inches by 4 inches by 4 inches. I had to use inch in order to say what I just said, but that doesn't mean that what I said is false, even though the thing is in itself almost certainly slightly different from 4 inches on any one of its three dimensions. All right, are there any questions so far? No? No questions? All right, so all of the mentioned entities arise because of our parcelings, griddings. So these are all what I call partitions. And Tom Bittner and Berit Brogard and I published a series of papers on what we call granular partition theory. And the idea behind granular partition theory is that very much of what we are doing when we are knowing things in the world involves the use of granular partitions. So the granular partitions may be at the level of countries, or they may be at the level of centimeters, or they may be at the level of cells, or they may be at the level of single human beings, or they may be at the level of entire civilizations. But in every case, we are utilizing granular partitions. And granular means that they're always at some level of granularity discrete. They're dividing up the world into units. So, a partition arises because we draw a complex Fiat boundary. So we have here now, 14 people. I just drew a Fiat boundary around all the objects in the room. The Fiat boundary closed off all non-person entities in the room, including all the things inside you. So it closed off your heart. Your hearts are outside this boundary. The only thing which is left is the stick figure, which is you. And then I count those stick figures, and I say there are 14. So we can see sometimes there's just one partition. So that is a partition, a one sculpture partition. That's Bishop Gurgur, GRGR, in the town of Split in, I guess, Croatia. And then there is the two object partition, which picks out one sculpture and one steeple. So that's the partition, and we can count, say, two objects. Now we can extend partitions. If we have a 12 object partition, we can extend it. We can add 6 more objects, or 12 more objects. And we can split the partition. So we can have all the things to the left on the no smoking zone. All the people in the no smoking zone are over here, and all the people in the smoking zone over there. But we can also merge partitions. We can take 2 partitions and put them together. So all the people in the restaurant, whether they are on the side of the no smokers or the smokers, are in this partition. And then, of course, we can refine a partition. And we've talked about this very early on when we talked about zooming. And then we can recognize that partitions can be skewed. So we have all the people in the room. We also have this is a rough and ready partition now. We have the different kinds of atmosphere. Very smoky, somewhat smoky with garlic, and just garlic. And remember, this is a partition, so the fact that these atmospheres are going to be flowing into each other is precisely what the partition allows us to ignore. And that's what we do when we do science very often. We want to build a representation of a continuous, rapidly changing reality in such a way that we can assign values and then see how those values change with time and so forth. All right, now BFO rests upon a number of different principles. One principle is the good old-fashioned principle of fallibilism. So we don't claim that BFO is true. Actually, we do, but officially we don't. Because it may be that we made mistakes when building it, and with those mistakes, then we will fix. We don't claim that it's complete. So we are going to be extending new terms into BFO slowly over the years. But the interesting principle underlying BFO from our present point of view is the principle of perspectival realism. And what this says is that multiple partitions can be true, or as we say here, veridical, in relation to the same reality. I mean the same reality. So that would be a case of this. So this is the partition of all the human cells in this room. This is a partition of all the people in this room. It's the same reality, but it's being partitioned at 2 different levels of granularity, namely coarse grain and fine grain. All right, now here we have a partition of the brain into brain regions, and you can see that there are subregions. For instance, SPRS, PRG, ASCS, which are subregions of the big region CS. And this is a 3-dimensional image that you can't see on this screen because it's a 2-dimensional screen. But if we had a 3-dimensional screen, I could show you that this is a 3-dimensional image. So that's where I got those 3-dimensional images from. So this is this is designed to show you that ontologies are also partitions, but now we're dealing with a complicated series of interrelated partitions which make up a bigger partition. So if we go back again to this here, this partition includes this partition as a sub-partition. And now we could put those two together and create an ontology. So at the level here we have 16 terms, no, 24 terms corresponding to what is here. And then at the next level we have, I don't know, 2,400 terms corresponding to what is here. So we would have a two-level ontology, which is in fact two partitions together with an ISA relation between them. Now, Linnaean hierarchies are also organized systems of partitions. So we have organism at the top, then we have animal, then we have mammal, reptile, beneath mammal we have human, cow, and so on. And that's more or less what we have here. So every ontology can be viewed as a system of partitions at different levels. Now, we're not quite talking about granularity here. So the relationship between animal and mammal is not a relationship where animal is a label for a more granular cell in a partition, and mammal is a label for a less granular cell. Rather, what we're dealing with is the entirety of the organism realm, which is partitioned by just a one-cell partition at the top of the ontology. And then as you go down, it's partitioned here by animal versus, I don't know, bacteria, or eukaryote versus prokaryote. And then as you go further down, it's partitioned, the very same bulk organism realm is partitioned into cow, mouse, rat, human, and so on. So partition theory and granular partition theory and ontology are closely connected. The job of the ontology is to capture a complex system of partitions, partitioning a given domain of reality, now in a more granular way, now in a less granular way, but not because we're dealing now with smaller parts, grains, and now with larger parts, but rather because we're dealing with smaller segments across a big reality rather than large segments across a big reality. Now, are you all happy with that? Yes.
When we see these partitions, we are considering only subclass of relations.
Only?
Subclass
Yeah.
of
Yeah.
relations.
Yeah.
Right? But there are other relations between the partitions.
Yep.
Yeah.
So I think I'm going to be talking about those as we go along. But if we don't, then you can come back to this because this is an important question. Any more? All right, so there are partitions of types which are captured at different levels in ontologies, because ontologies are representations of types or classes. But then there are also partitions in the level of, and the red, green, blue is an example there, but also eukaryote, prokaryote, and rat, mouse, cow, and so on. They're all partitions at the level of classes. But Poland versus Germany is a partition at the level of instances. Typically, people do not kill each other over types, they kill each other over instances. Nation state versus colony is at the level. And now, as I just said, partitions at the level of types are connected together within those complex structures which are called ontologies. Now, I use the term here, bona fide boundary. I guess I should explain that term. So the boundary between non-hypertension and hypertension is a Fiat boundary. The boundary between Germany and Poland is a Fiat boundary. What that means is that it's a boundary, but there is no physical discontinuity. The boundary between this dog and this dog is a bona fide boundary because there is a physical discontinuity between this dog and that dog. or between me and this chair. BFO at the moment does not have a category of bona fide boundaries because if you examine at a sufficiently fine granularity the boundary between me and the atmosphere around me, you will find that there is no sharp line. And so we are, in a certain sense, creating an artifact when we think about boundaries around things like organisms or tables. But still, they are much more like physical discontinuities than the lack of a physical discontinuity that we find, for instance, when we consider the left hand or the right hand side of a table, or the boundary between non-hypertension and hypertension along the dimension of blood pressure. So, bona fide objects are those objects which exist independently of our partitions. And this is part of what is meant earlier on by saying the world knows planets, or the world knows cells, or the world knows animals. What that means is that independently of our partitions, there are cells, planets, animals, because there are physical discontinuities separating those things. There are no legs. I mean, organism legs. There might be table legs, but there are no organism legs, or noses, or heads, independent of our partitions. And there is certainly no hypertension independently of our partitions. And there are no centimeters independently of our partitions. So there are quarks, and there are or human beings independently of our partitions. And there are molecules and atoms independently of our partitions. So there are helium molecules independently of our partitions. Helium atoms, I should have said. We create then all kinds of Fiat partitions. And we do this whenever we refer to anything, whenever we perceive anything, whenever we classify, count, measure, map. All of these things are ways of partitioning. All of these involve partitioning reality. We can't perceive anything without separating the thing we perceive from its environment. We can't refer to anything without separating the thing that we refer to from its environment. In that latter case, it might be the environment which is everything else. In the perceptual case, it will be the environment which is our visual field or sensory field. So all of these things are a kind of gridding activity, and we're back now to something that we already met several times, which is Alberti's grid. Now, we can't count without partitions, and the feature of counting is that the partitions impose a certain homogeneity constraint. So we can count apples, or we can count pieces of fruit, or we can count pieces of food even. But we can't count without having some kind of count noun. And then we count. I'm sorry, this is when I was using animation in my PowerPoint slide, which I stopped doing a long time ago for obvious reasons. It's even worse if you want to go back. All right, so Frege, as some of you will know, had a whole theory of number, which is the foundation for a whole theory of arithmetic and of the rest of mathematics. And on Frege's view, numbers belong to the realm of concepts. I think Frege was wrong. I think numbers belong to the realm of partitions. And the problem with Frege's view is that the concepts in people's heads, or the concepts in concept realm, the realm of Platonic concepts, which is more or less what Frege had in mind, are not, in my view anyway, sufficiently closely tied to the actual bananas that you are counting. So we're not interested in the concept banana when we count. We're interested in those things in the environment of the counter, which, in Frege's terms, fall under the concept banana. But then in order to have those things available for counting, we need to partition them from their environments and from non-banana entities. So we can't count without partitions. I also don't think that all partitions correspond to concepts in any reasonably well-defined sense of concept. But that's another story. All right, so that's what we have without partitions. There's more animation for you. So how many are there here? So what's the number of this? And Frege, of course, would say, well, if you want leaf, then you get to count leaves. And there is, I suppose, a certain number, which is the number of leaves. We'd have to do something about the boundaries up there. It would be quite difficult. Now we'd have the stalks. We could count the stalks or the trunks or whatever they are. We could count the branches. But in any case, we're going to have to create corresponding partitions, and we're going to have to think, well, are the leaves up here going to be inside our partition or not? Because they're not really clearly in the picture. And we can't count the number of leaves here unless we impose a partition on the phenomenon that we see before us, and in doing that, that's an extra exercise which is non-trivial and will involve a certain amount of subjective decision. All right, now partitions can sometimes create objects. So I have a lot of meat. We're coming in the next few slides. So these are Fiat meat cuts, of which in the German standard meat cut doctrine there are exactly 14. This one anyway. I guess they don't count all 4 legs, but that's because they're all the same cut. And so this is a better view, and it starts with the least edible, and then it goes up to the English, because the English were the people who were really good at roast beef, and the French call the English roast beef. And we wanted always to have the best pieces, and then beneath the English are the gusto pieces, and then the rear pieces, and then the Hungarian pieces, and then the fat stuff. And all of these are Fiat partitions. So this is the really good stuff. This is the tenderloin. And the reason it's the best piece is because that's the muscle which is least used. So if you use a muscle, that does something to the taste. Now these are Mexican beef cuts. There was something English here, but I can't find it now. Oh, T-bone. So you see they cut the cow slightly differently. Roast beef is here. So the Mexican for roast beef is roast beef. This is a partition along 2 further axes of the same beef or meat generally. So this axis is the degree of marbling, and you want to have slightly abundant marbling. The marbling is fat, but it contributes to the taste. And if you have too much fat, then it takes away from the taste. So what you want is this fresh stuff up here. And then down here, the things which go into the cutter. I don't know what that quite means. But this is already, I think, I don't know, some years or months. So the stuff out here is not really fresh. So what you want is triple A prime, slightly abundant English, or tenderloin. And that's the horse. And here, pretty much, you only want A, which is good enough to be steak. You don't want anything else. Although in France, they still can do things with the other parts of the horse. And then there's the elk. which I guess is pretty good, particularly the tenderloin, which is here, and bison. So it seems there's a lot more good meat on a bison, but maybe they just don't have a sufficiently granular partition. And then crocodile, and there's the tenderloin, and panda, which is hard to get. But you should try and get some, because it won't be there forever. All right. Now, you shouldn't eat this. This comes from a European Union customs manual. In order to export or import shoes through the European Union, they have to satisfy the European Union shoe regulation. And that means they all have to have labels, and this is a partition. So there are three kinds of material: textile, lining, and leather. And then those materials can be glued together in different ways, but they have to satisfy certain criteria, which are laid down in this incredibly long PDF file. Explanatory notes to the combined nomenclature of the European Union. So this is not just about shoes, it's about live animals, meat and edible meat, offal, fish and crustaceans, mollusks and other aquatic invertebrates, birds, eggs, natural honey, and so on. So it goes all the way down, and then it gets to shoes. So this is the diagrams and text below give an example of how to determine the material of the upper, which is the top part of the shoe. And a bit further down, they tell you how to distinguish the forequarter from the hindquarter. And they do this in all the European languages. So you could get this PDF file in Catalan if you wanted. And they just tell you how to distinguish between the jowls and the chaps, which is non-trivial. All right, so what we see from this, and indeed from all the other sneaker and the beef diagrams also, is that we have to distinguish between two kinds of ontologies. On the one hand, there are those ontologies which represent distinctions in reality. So the distinction between a mammal and a reptile is a distinction which we discovered. We're dealing with partitions, but we're dealing with partitions which reflect what is out there in the world. But when we're distinguishing between the chaps and the jowls, then we're not dealing with something which is a scientific fact of the matter. We're dealing with something which is an administrative fact. And so there are two kinds of ontologies. There are scientific ontologies, like the gene ontology and the foundational model of anatomy and the cell ontology and the protein ontology and many other chemistry ontologies. Those are all scientific. The types of entities which they deal with are types of entities which existed before there was science, before there was administration, before there was language. We have now developed language to describe different kinds of atoms, but those different kinds existed, and the differences between them existed before there were people and before there was cognition. But the distinction between jowls and chaps, or the distinction between type A protected airspace over airports and type B protected airspace over airports, is a distinction which only exists because of some administrative fiat. And so when dealing with ontologies, we have to be very careful to work out whether we're dealing with scientific ontologies or administrative ontologies. And in many cases, we're dealing with both. So when you do a clinical trial, for instance, then you will create a fiat category, which is the category of subjects who are eligible for your trial. And it might be all people age 13 or over who have been smoking for 5 years or more and who have symptoms of type 2 diabetes and maybe 3 more other criteria like that. And you recruit those people into your trial. This is a trial which is being performed for scientific purposes. And then you divide them into 2 groups, those who will get the placebo and those who will get the drug that you're testing. And that division between the placebo and the non-placebo is also a Fiat division. It's an administrative division. And in order to perform scientific experiments, you're practically always going to be involved in making administrative divisions, Fiat partitions, of those kinds. But the reason why you carry out the experiment has nothing to do with those Fiat divisions. You carry out the experiment in order to find out scientific facts about this drug, which is a chemical substance, which does not depend upon our Fiat partition, and about these kinds of organisms, namely human beings. How does this drug affect human beings? That's what you're trying to find out. How does it help with diabetes? That's what you're trying to find out. So you do science in part by doing administrative division of the objects in your domain in order to do experiments, compare the results of the experiments on the subgroups of objects that you created, and then draw general scientific conclusions about the effects of this particular stimulus as contrasted with the effects of that other stimulus or placebo. All right, so we talked already about mild, moderate, and severe hypertension. And we talked about the leg. We can also talk about the tail. So we talk about tails and we talk about torsos. But the division between tails and torsos is a Fiat division. And so is the division of Kansas into counties. Yes?
I'm not clear on the criteria between Fiat, these Fiat distinctions.
Administrative distinctions.
Yeah, but you did toss out the idea, the criterion of things existing before we were there to classify them. Didn't torsos and tails exist before we were there?
Yes, so if you look at the foundational model of anatomy, I mean, it doesn't contain tail because people don't have tails, and it's an anatomy for people. It does contain leg, head, arm, as well as lung. Now, it's, I believe, a mixed administrative scientific ontology. The way in which it's expressed is that there are 2 kinds of parts in the foundational model of anatomy. There are structural parts, anatomical structures like the heart and the lungs and the kidneys. And then there are what are called regional parts. Now, regional parts are things like the head, the arm, the foot, the toe. Those regional parts are not parts in the sense in which the heart or the lungs are parts. You can't take out the head. You have to cut it. You can't examine the... You can examine the heart. You can take it out and you can do experiments with it and then put it back. You can't do that with a head. Now, you can't do it yet, anyway. Now, it's scientifically very important to distinguish regional parts. So we want to talk about the head and the arm just as we want to talk about the lungs and the kidney. But they're still dealt with differently in the foundational model of anatomy, which is a kind of gold standard for anatomical ontologies. Now, if we think about something like Poland, then it's clear that Poland did not exist before. I hope it's clear anyway. Poland did not exist before there were people. But if we talk about the distinction between torso and tail, then it's not quite so clear. But if we distinguish between the whole cat and the heart of the cat or the eye of the cat, then it is clear again. So there we're dealing with bona fide distinctions, structural distinctions. In the case of the this cat and that cat, we're dealing with bona fide distinctions. In the case of the cat and the tail, it's a kind of halfway house. I can go either way, but the FMA does indeed make a distinction between different kinds of parts, exactly corresponding to the distinction I'm trying to make. Yeah?
So what about like the distinction between, say, like hearts and arteries? Because they're connected, and it seems like there's not a clear
Yes, so so everything inside your body is connected to everything else except your blood cells. The only clear, let's put it this way, the only clear parts of your body which are not connected to the other parts of your body are the blood cells. There are things inside you which are not connected, trillions of bacteria, but it's not clear that they are parts of you. They may just be resident tenants or something like that. So the heart is connected to other parts of the body, particularly it's connected to the arteries. Now, that means that we're dealing with a case which is a bit like the cat tail case. So this is the artery and this is the heart. Some people would say that means that the distinction between the heart and the arteries is a Fiat distinction. It's just like the distinction between the torso and the tail. But the surface area of the boundary between the tail and the cat is 100% of the area of the tail along that dimension. So we're dealing here with, well, actually, no, let me put this in another way. The surface area of the heart is a much larger, start again. The surface of the heart, which is exposed to the cavity around the heart, is a very large fraction of the surface area of the heart taken in its totality. So the surface area of the heart where it's connected to arteries is in other words, a small fraction of the total surface area of the heart. Now, when we say the heart is separated by its surroundings by a bona fide boundary, that includes certain gaps, which are those places where the heart is connected to something in its environment, namely the artery. So it's a little bit like the question, do lakes exist? So every lake has at least one waterway which brings water into it, and at least one waterway in which water is taken out of it. Does that mean there are no such things as lakes? Geographers who work out questions of geographic ontology are of one mind that lakes exist, because the area taken up by the inlet and the outlet is tiny compared to the total, the length of the circumference of the lake, which is taken up by the inlet and outlet, is a tiny fraction of the circumference of the rest of the lake. And so we are dealing with three kinds of cases. We're dealing with cases where we have a complete boundary, as for instance in your case, cases where we have no discontinuity, as in the case of Switzerland, which is completely surrounded by other countries. And then in the middle, we're dealing with cases where we have an almost complete boundary with inlets and outlets, or pores, or gap. Even you have pores, which are holes in the surface of your skin. Now, those structures, large object like a lake or a heart, small inlets, conduits, pipes, were there before there were people. Because if your heart, or if some organism's heart didn't have arteries, that organism would be dead and he wouldn't have had any descendants, and so the organism type to which that organism belonged would not have survived. So these structures, big objects, small inlets, are there before there were people. Now, or before there was cognition, before there was classification. How we describe those structures it involves a certain amount of sophisticated thinking, but the sophisticated thinking is going to end up with, there are legs which have inlets and outlets, there are hearts which have arteries. I'm going into this issue at some length because there is a philosopher by the name of Elseline Kingma in Holland who holds that the fetus is a part of the mother. And her argument is that it's not like a bullet, for instance, which may be inside your body, or a bacterium which is inside your body and not connected to the rest of your body. The fetus is connected to the rest of your body through the placenta. And if it's connected to the rest of your body through the placenta, then it's just like the heart. And since the heart is part of your body, then it must follow that the fetus is part of your body. Now, this view is shared by zero obstetricians or developmental anatomists. So she may be the only living human being who has thought about these matters carefully, who holds this view. Now, I conclude that she's wrong. She's coming to Buffalo, actually, later in this.
What's her name again?
Elseline Kingma. So she is not a wacko continental type. She is otherwise quite sensible. But she holds that the fetus is a part of the mother until the baby is born, and then it becomes a baby. I hold that the baby is like a bacterium. It's resident. It's a resident tenant. Yes?
Feel free to say no, but I have a question about Buffo, and then depending on the answer.
Yeah.
So when I read about Buffo, it often says that it's formal, and then it has, Buffo itself is formal, and it has an identity symbol that says, that means domain neutral.
And it has...
identity symbol that says domain neutral. It's
Yes.
supposed to be domain neutral.
Yeah.
But when I think about Fiat partitions and things like this, it seems that that's not domain neutral.
You mean only humans
So
could
there
have
were-
created
there
fiat
were-
boundaries?
So there were things before us that existed, and there were boundaries out there.
Yes.
So the neutrality, it seems like to my ear at least, would be an upper level ontology would be able to describe or define things like the fiat stuff in terms of, a subdomain ontology would be able to define continuum or fiat stuff in terms of the upper level ontology. But the upper level ontology shouldn't include things like fiat partition.
Okay, good. So, when the original papers on fiat objects and fiat boundaries came out, and this was before I started working with Achille Varzi, who we worked on the formalization of that material, I held that fiat objects were created by human fiat. Now, I have since become convinced that while the obvious examples of fiat boundaries, and like Poland, or Utah is better, because it's square, anyway, rectangular. While the obvious examples are examples of phenomena which involve human creation, fiat creation, drawing of thresholds, hypertension is another one. There are many examples of fiat boundaries where no human being, on the instance level of course, where no human being ever drew the fiat boundary, but where science deals with the phenomena in question as if there were fiat boundaries. And the artery versus heart, every artery is connected to a heart at a fiat boundary. Every mouth, even mouths of very, very, very primitive creatures, when it opens, creates a fiat boundary between the organism and the exterior. Yeah. So now I don't hold the fiat boundaries are the creation of humans. I think that they are, I have to be careful here. I can't say parts. I guess I can say parts. They're parts of the structure of reality. I think boundaries are parts of the things they bound in many cases. So I think I'm safe from that particular challenge. Yes?
Again, on the distinction between scientific ontology and administrative
Yeah.
ontology. So it's not clear to me, again, the distinction, because scientific ontology is about something that always existed, whereas administrative ontology is not about something.
So we have to be more careful. So the world is changing all the time. There are new species coming into existence. New chemicals are being synthesized and so forth. Those new chemicals which are synthesized could only have existed if there were people doing science, but they were synthesized in reality. They didn't come to into existence because somebody said everything above this line counts as a, I don't know, gluon. They came into existence because people did the real physical work to create these new molecules. So everything like that, which comes into existence as a result of the fact that either nature does physical work or the planet does physical work, volcanoes, for instance, or chemists in labs or physicists in working with colliders do physical work. Everything like that is part of reality that is to be studied by science. Now, then, actually, let me be even more careful. Everything like that is part of the reality for which we develop scientific ontology. Then we have particular cultures where people develop particular kinds of partitions, for instance, into tax brackets. And those partitions are a product of administrative fiat. They don't correspond to any discontinuities in reality. They don't correspond to any differences in physical or chemical makeup. They're just fiat thresholds. Those kinds of phenomena are the object of administrative ontology. There will be some phenomena in the middle which could be dealt with both scientifically and administratively. So somebody who is a specialist, let's suppose that we agree that tails are products of administrative fiat. There might be a science of tail diseases in mice. And then tail would become a part of the scientific ontology for that scientific activity. So very often when you're doing ontology, you discover that there are clear cases of this, clear cases of not this, but then also cases in the middle where they're not clearly either this or not this. That doesn't mean that there are no clear cases of this, nor does it mean that there are no clear cases of not this. It just means you have to be careful about the cases in the middle.
So in the scientific ontology, more than always existed, we should say existence in reality, whereas in administrative ontology, we should speak about something. We should talk about something like existence dependence, which depends on our
Fiat demarcations or fiat thresholds or fiat decisions even.
Okay. So you have two different notions of existence here.
No, I think everything exists. Basta. Some things exist because of fiat decisions, and some things exist because of the way nature evolves, or the way the world evolves. So they are enrichments of what exists in the way the world evolves sense. There are people who are in the upper tax bracket. The upper tax bracket exists.
In the same way in which atoms exist?
I don't want to go down that road.
Okay. Because I think it's wrong to say that.
I do not suffer from a prejudice in favor of the physical. So we were talking about obligations and debts, I think, and money. I think all of those things exist. Money sounds to me a bit like centimeter. There could be no money if there were no dollar, or peso, or lira, or euro, even. Any more questions? All right, so one of the counties of Kansas is called Smith. I just thought I would mention it.
Also, Douglas County is where we keep all the bad drivers,
I see.
in case you're curious.
Is that where the Irish live, or what?
It's where the Kansas City people are.
Douglas County?
Yeah, it's towards the east, right next to Shawnee.
There, Douglas, yes. All right, so we're now on the ontology of maps. So when we are developing an ontology, we are creating a representation of types. We've gone through this over and over again. And then when we build a database or write a diary or write a newspaper article, we're talking about the instances of those types. And so now we have a place where domestic cow are kept. I guess we say domestic cows. We wouldn't say domestic sheeps, but we would say domestic cows. So of a certain breed and species. And this is the nameplate here. This is the cow of the breed. This is a Holstein Bos Taurus. Now, this stuff is in the ontology. So the ontology will tell us about breeds and species because breeds and species are types. At least that's how we'll think of them for the moment. And that's an instance of one of the types in that ontology over there. And that's a really slow animation. I really must kill the animations. All right. So a label in a zoo is a mapping between an animal instance and an animal type. And I say then that all scientific language is built around mappings of this sort between instances and types. So whenever you do an experiment, you look at instances. You examine them, you poke them, you disturb them, and then you measure the results. And you do this not because they are the instances that they are. You don't care about this particular cow. You do it because they're instances of a certain type. And you want to see how the instances of this type will behave in these and these circumstances of these and those types. So science is about types, but it works because people can study instances. All right, now the same thing happens when you have a map. This is a map of instances. So remember the cow. This is a map of a certain part of reality. I think it's California. And this is the legend. So coniferous trees, deciduous trees, thick herbaceous trees, and so on, are types of tree. Actually, they're types of ground, because we have bare ground, we have water, and we have shadow. What does shadow mean on that?
I don't know.
He's a geographer, he should know.
Yeah. But it seems like the remote sensing data, so I'm not familiar with that. Do you know?
What does shadow mean on a map cover, a land cover map? So it means it's too shady to grow anything. I don't know. Anyway, it doesn't matter. This is a representation of instances. This is a real piece of the planet with a real river and real lakes and real coniferous forests. And this is an ontology over here. An ontology of different kinds of land cover. It's not a very...
I know the meaning of the shadow.
Yeah.
Because when we take the kinds of photos, the airplane moving around, so because of the angle to the airplane to the tree, the shadow should be made.
I half believe you.
That explains why it's only on one side.
Well, no, but the shadow's down here.
So what's unclassified then?
Well, that just shows you that it's a bad ontology, that they have so that here they don't know what it is.
That's the nothing.
It doesn't exist.
Could be that's... so there is a department, I only heard about this lunch break, there's a department of Homeland Security, with, the head of which is called the Director of Deceit and Denial. And I guess part of that, I'm assuming it's a man, of that man's job is to make sure that Google Maps don't know what's here. I don't know. Has to do something. All right, so a map is a mapping between points in reality on the surface of the planet and types represented in a legend. It's just like the herbaceous cow. No, Holstein cow. The label is a little map. It tells you the type, which it's a map of, and it tells you the instance, and it maps to the type. So this is a map of a really nice portion of reality. I mean, there's stuff to the right. Yeah. And then every map has yellow arrows, yellowish green arrows, sticking out of its back, which you can't see unless you look very carefully. And these yellowish green arrows link the map, the point on the map where they start, to the point on the planet where they end. So a map is a mapping between points on a visual representation and points on the planet. Now we're getting to measurement. So that is, from the point of view of mappings and maps, quite interesting. So this is a map between a place called Dismal Creek Falls over here and this pole here, and it tells you that the distance is 0.2 somethings. Now that sounds trivial, but it's not trivial, says he, waving his finger. All right. So we've already had all of this. So the world knows no inches, feet, centimeters, because there are no such joints in reality. We created these. These are threshold divisions. But they are portmanteau threshold divisions. We can carry them around and stick them on reality wherever we like. So when we make a map, we may stick on reality a line which says the distance between this pole and Dismal Falls is 0.2 somethings. So we've created the new object, which is the distance between this pole and dorsal Dismal Falls. Similarly, when we measure this and say it's 3 inches long, then we are creating a mapping between a measurement result, 3 inches, and a certain piece of reality. Now, the reality was always 3 inches long. In some sense. So if this had been a piece of granite, which we found in some Pleistocene archaeological site, which is 4 million years old, that was 3 inches in diameter, it would still have been 3 inches in diameter 4 million years ago. But there were no inches then. So there was a length of this thing, which we can now measure, and which we can now say is 4 inches long. That length has not changed. Pieces of granite do not change in the way that pieces of ice change, for instance. But there is nevertheless something which changed in the interval between when the granite was formed and when we state the measurement datum. And what changed was the institution of measurement, which is a socio-cultural phenomenon which was created by human beings in order to do science, in order to understand the structure of reality. And now, to go back to the question of administrative versus scientific ontology, every science involves the use of these things called units of measure, which are administrative entities. And just as the European Union has a long catalogue of parts of cows and shoes and so forth, so the international body which is in charge of units of measure, the International Standards Organization, or I don't know what the name of the units organization is, that body is an administrative body. They make decisions about units of measure by fiat. And they are modified and changed as new equipment is developed, as new science is developed about how particular units of measure work. All right. So measurement belongs to the realm of partitions. When we say that the length of this iPhone is 3 inches. What we're doing, we're counting. All counting involves partitions. We're counting 3 equal parts along the relevant dimension of the iPhone. Don't tell me it's 4 inches. And that's a partition. And then we count those cells and we say 1, 2, 3, 3 inches long. So every measurement involves something like that. And that's true whether it's a quantitative measurement or a qualitative measurement. So, this is an example of a kind of skewness of partitions. So the measurements, results captured in centimeters, millimeters, can be transformed mathematically into measurement results in inches. But the two partitions themselves are not comparable in the sense that if you partition a certain length in millimeters, you're not going to get any cells which are identical to the cells which you get if you partition in inches or fractions of inches. And then, as we said earlier, partitions can be more or less refined. So we can have an inch-based partition which is more refined than another inch-based partition. And here we just have a more granular division of what is one and the same thing, namely an inch. So what was true of partitions in general, with the Bishop Guruguru statue and so forth, is now seen to be true of those kinds of partitions which are partitions of measurable dimensions. Now, we haven't got the full story here. It's very easy to do this kind of thing with inches. It's less easy to do it with other kinds of units of measure, as we will see. Now, when we make partitions and when we count and when we measure, we may be interested in very precise measurements, or we may be interested in very rough measurements. So we might say a given object is 3 inches long and mean it's 3.000000 inches. It's precisely 3 inches long to 8 decimal places. But we might mean it's 3 inches long roughly. And we may not care about even a half-inch difference either way. So to say that something is 3 inches long is underspecified along the dimension of precision. And we're talking now about a certain quality of partitions. Some partitions are marked by a phenomenon of vagueness relative to other partitions which are marked by the feature of being more precise. And that's related to the issue of granularity, but it's not the identical issue. So we'll get a more precise partition if we use we'll get a more precise measurement if we use a more granular measuring rod. All right, so what is an inch? That's the kind of question that philosophers are allowed to ask. And I have an answer. Kant did not have an answer. And Plato didn't even have the question. All right, so there are fiat instances. For instance, the inch, which is the first inch along the back of my iPhone, is an instance of the type inch. And so is the second inch, and so is the third inch. And each of those inches has the same length. They're all roughly 1 inch long. What that means is that they are all instances of the same type, inch. So we have the instance inch, of which there are many, at least 3 on my iPhone. And then we have the type inch. And the type inch is a fiat type. What that means is that it's a type, unlike lion or cow or mouse or cell or planet, which is a product exclusively of our making fiat thresholds along the length dimension. And so it's a socio-cultural institution. It's something that we created namely a practice, a technique for creating fiat thresholds, which led then to the creation of many, many measuring rods, in which which made it possible to measure things in inches. And those measuring rods carry instances which have been specially crafted to be exactly instances of this exact fiat type called inch. Any questions? You all convinced? You're only half convinced.
I mean, I'm sorry. Did you?
No, you go first.
Go ahead.
So, I might buy it for inches and other such
Yeah.
units of measure. I'm not sure I'm convinced about some of the comments you made about numbers earlier. Specifically, it seems like this could be open to some sort of like Klein-Putnam dispensability argument where, ratios and what have you exist in nature. Things like gravitational constants, speeds, and what have you, velocities. And if those things exist, it seems like those are mathematical entities, which might be
Good. All right. So let's take the gravitational constant. I certainly think that the gravitational constant existed in reality long before there were things like people.
Right.
It's clear that, given certain assumptions which seem reasonable about the uniformity of nature and so forth, it's clear that when we measure it today, we're measuring the same thing as we would have been measuring then, and the value is the same. But then, centimeters and seconds didn't exist. And so what we are describing is not something which is clothed in any particular unit of measure garment.
Right.
So the naked gravitational constant is a scientific object which is not the product of our fiat.
Sure.
And now that's interesting because it tells us that not just gravity, but also acceleration and time are not products of our fiat decisions or demarcations or threshold creations. So they are dimensions which are a part of nature.
So I guess my question is getting at, what about the relationship or ratio between them? And it seems like to have a relationship and ratio, you have to have some sort of number. Right?
So the reason why I'm hesitating is because I'm much less confident about ratios than I am about straight categorical measures along simple measurement dimensions like length. We're coming back to ratios later on from this point of view, but I will have disappointingly little to say. So I'm just warning you.
Okay.
Neil.
I guess maybe I need more examples, but it seems strange to me to think of instances of inches as instances of lengths. But maybe I shouldn't.
What else would they be?
Maybe I shouldn't feel strange about that at all. I don't know, because I'm used to thinking of units of measurement as abstract entities that get applied to things, not as immanent descriptions of the way the world is.
So no, don't say description there. I think that there are immanent qualities.
Yeah.
Color, temperature, mass, and so forth. Specific gravity. And I think length is an immanent quality of a thing with a length. And now that immanent quality is a quality instance. It can be measurably the same. So it can be, when we measure it, the same as an immanent length quality of some other object. And if we measure it using a measuring rod, we can find that it's the same as everything which is 7.5 inches long. That seems to me to be rather beautiful, actually. It's trivial, but it's also beautiful. All right. So this is back now to the acceleration, time, and so on. So just as acceleration and time existed before our fiat demarcation, so also we can slice up this Fiat. It's a Fiat quality type, which is a continuous dimension. So there can be lengths at any granularity of precision, any precision. And we can slice it up in different ways. We chose to slice it up in inches, and then the French came along and messed it up. And so now we have to reckon in centimeters as well, which is and there are no infinitesimal portions of length. We can make lengths which are as small as we want. And I don't know about the Planck length. It could be that there are bona fide length unit types, so that if we measured everything in multiples of Planck length, we would be measuring something which is bona fide. But that doesn't sound convincing. All right. So.
Maybe one other question.
Yes.
So, when I think about perspectival realism, I usually think of Nietzsche, which you don't think of at all, probably. But one of the ways in which he thought about perspectives in many of the same ways that you do, but he was also thinking of the ways in which perspectives can be socially motivated by our needs, so they can be better and worse perspectives. And some of the categories that you've thrown up here have also kind of crossed the evaluative descriptive scale.
Yeah.
So,
Okay, so my line on this is that those socio-cultural institutions like measurement which survive because they are useful, and they are useful, and this is the key difference between this kind of approach. Notice that I didn't say my approach, I said this kind of approach. And Nietzsche is that the reason why they are useful is because they are true. In other words, it's true that my phone is 3 inches long. But Nietzsche wouldn't talk like that. That would be a sign of weakness from his point.
He would talk like that every Tuesday or something, but not the rest of the week. You went back and forth.
Yeah, a little bit. So there are other ways. Wittgenstein has this small thought experiment. Let's suppose that people would sell and buy carpets not according to their surface area, but according to the height of the pile. I mean, he meant piles of carpet. That is a thought experiment which has absolutely no consequences, because such a society such a league of carpet trades people would not survive. Inches survive, even today. All right, now, so you can read this. This is the International System of Units, and down the left we have the base units: kilogram, length, mass, length, time, amount of substance, electric current, thermodynamic temperature, and luminous intensity. And then we have derived units. So first of all, things like volume, which is length cubed. And volume I can deal with. Area I can deal with. Now velocity I can deal with, but and when I say I mean BFO. Velocity is more difficult. It's a ratio. And acceleration is, well, actually, once you've worked out how to deal with velocity, dealing with the acceleration is just one step further. I could talk at some length about how to deal with velocity if we wanted, but I'd have to write on the blackboard, and then the posterity would not have a record. And it might be embarrassingly bad. But I know, I don't know how to deal with the other ones. So I maybe could get frequency. BFO still needs an account of force and energy. So I think I know roughly how energy would go. But we don't really have a good way of dealing with anything in the derived units. And now those things are used to measure something which is real. And so each of these dimensions is a dimension of reality. They wouldn't be in the system of units if they weren't measuring something real. And the test is utility. Utility for doing science, but also utility for doing engineering. So there must be a dimension of reality which is called potential electromotive force. And we need eventually to have, not necessarily inside BFO, but inside some domain ontology of BFO, representations of all of these units of measure. In the same way that we do length, we have a dimension and we have Fiat demarcations along the dimension, which are then used in technical devices to measure certain phenomena. And so we need a good ontology of technical devices. And we are beginning now to start working out some of the ontology of engineering, which is where some, perhaps all of this work will eventually land. So the existing units of measure ontologies are really just lists of what the system of units already represents. So what I think we need to do is to have an analysis of units of measure on the derived side, which is analogous to the analysis of length, which I just presented in its potted version a few minutes ago. And so I think we can do the same thing with time. So there, the technical device will be something like a clock. We can do it with temperature, and there the device will be some kind of thermometer, and so on. And we have to be careful. The reason why there are instances of the type inch in the world is not because there are measuring rods. The reason why there are instances of the type inch in the world is because there is a social institution of describing the autonomously existing bona fide qualities called lengths using arbitrary length units, standard length units of exactly 1 inch in length to formulate the result of measurement. So the social institution of using the word inch and the social institution of measuring using certain kinds of devices like measuring rods both exist as parts of the history of mankind. What they measure are lengths which existed from the beginning of time. Or anyway, after a few milliseconds after the Big Bang, when some pieces of granite had settled down. All right. Now, and then we have the question, how do we deal with complex units? And this is, I think, a really important subject. I have not done the necessary work to deal. I've done something in regard to acceleration, but not, and also velocity, but not yet enough. All right, then we have the phenomenon of vagueness. We've talked a little bit about that. So every measuring rod has a lower level of precision. There are always things which are more precise, which it does not measure. So another way of viewing all of this is Alberti's grid. So when we measure something, we lay a grid upon the something, and then we have a unit type which divides the something into equal portions, and then we count the number of equal portions, and that's the result of the measurement. Now that works for extensive magnitudes like time or length. It doesn't work for temperature. So we use a grid on a temperature scale in order to read off the temperature value, but you don't get a temperature of 20 degrees by taking 2 instances of 10-degree temperature and adding them together, in the way in which you get a 20-inch length by adding 2 10-inch lengths together. And so the theory of intensive magnitudes is going to have to be different from the theory of extensive magnitudes. And if you're interested in that kind of question, which is very interesting, because things like pain are intensive magnitudes, then the book by Ingvar Johansson called Ontological Investigations, which I've referred to before, is a very good place to start. In fact, one of Ingvar's papers on units of measure is listed on the wiki as a good piece of reading matter to accompany this lecture. All right, so we have an active measurement. This is extensive magnitudes always. We have a portion of reality. We have a dependent magnitude, which is a distance. And we have an independent bearer of this dependent magnitude, which is the road. So the distance is a quality of that particular piece of road. And then we have a measuring rod. We lay the measuring rod against the piece of road, and we count the cells in the partition created by the measuring rod, and we get the answer. So we project the partition onto the reality, which has endpoints, and we get the answer when we count the cells in the grid thereby created. And so these are all the things which are part of an act of measuring length. And I'm not going to go through the list. And probably now I would want to make it even more complicated. But actually it's very simple. It's just repeating what I just said. So the periodic table is an ontology created in support of science, which is a domain ontology. And there are other kinds of ontologies. So BFO is an upper level integrating ontology, and there are others, famous ones, one of them from Italy, which is a famous country. The other one has a Japanese name. Then there are administrative ontologies, which are developed for various commercial and other purposes. So Amazon.com has an ontology. The Library of Congress catalog is an ontology, an administrative ontology. And then we've seen Go and FMA and SNOMED before. So these are the types of ontologies. And as I say, virtually every scientific activity will involve at least something here, and therefore also something here, because every one of these is going to have some upper level, and also something down here. Because to do science, you need to do experiments, and to do experiments, you need to partition instances in reality. So, the reason why these slides seem boring is because we're already in the 9th week, and you already know a lot about ontology, so I don't need to say all of this anymore. All right, so this is something which I have said before, but I've never said it in one foul swoop in this class. So, in every domain, now, people are developing terminologies, dictionaries, thesauri. So the Google and Amazon.com are just one example. The military is doing it. The health services are doing it. They're trying to create data dictionaries. They're trying to unify the information that they have in different databases by having common terminologies. So this is a general desire on the part of many large and small institutions today. But how do we do this? If each group creates its own terminology, then the data that each group creates will not be compatible with the data which other groups create. So how do we create good terminologies which will foster data sharing and data comparison and data analysis? Well, we need some evidence for the terminology being good. And one kind of evidence would be authority. So if somebody, Aristotle or God or somebody, knows how to build a good terminology, then you just ask them to do it, and then you have your good terminology. That doesn't sound very good. The next way of doing it would be to say that the first people who are developing a terminology for a given field will get to own the terminology for that field, and everyone would have to follow in their footsteps. But then gradually there are going to be people who are bad at doing terminology work, who develop ontologies in a given field, and no one wants to follow their work because it's clearly second rate. So we need still a kind of evidence. So the next criterion is to take all the candidate terminologies that there are and then pick the best. But then we need to know on what basis we will determine a given terminology as the best. And now the answer which BFO is based upon, which is called ontological realism, says that the way we determine what is a good terminology is by the degree to which it conforms to our scientific understanding of the relevant domain. So the periodic table of Minkowski is a good terminology for describing the chemical elements because it corresponds exactly to our understanding of the chemical elements based on empirical science. And the gene ontology is a good ontology of gene product attributes because it corresponds to our best understanding of the way in which gene products work, where they work, and what biological phenomena they contribute to. So we have been developing this program of ontological realism, and now BFO is not helped by this. So BFO is not a scientific ontology. It's not an ontology which is based on scientific evidence. Rather, it's an ontology which fills the gaps between the ontologies which are based on scientific evidence. And it gives you an account of the very general terms which every scientific ontology has to use when it starts to make definitions, terms like object and process. So then you have to modify A4 by saying that terminologies should either be based on our knowledge of reality as revealed by science, or it should be based on our knowledge of how to do the formal ontology, which can serve as a starting point for the way scientific ontologies will be developed. And then the next stage after that is to look at administrative ontologies and to say that an administrative ontology is going to be good to the degree that it is consistent with the best scientific ontologies in that domain. What that means is that for formal ontologies, there is a certain degree of choice. So it could very well be that BFO and Dolce and Sumo are all equally good candidates for being the top-level ontology from which scientific ontologies are developed. And when I first started doing this work, I did have an idea that we could have a kind of empirical test. So I wasn't thinking of Dolce and Sumo. I was thinking of Kant or Heraclitus or Plato or E.J. Lowe or David Armstrong. So dead white European ontologists. And then BFO. And we would see which of those would work best for science. And on that basis, of course, I'm winning. But no one was impressed. So I stopped making that kind of argument. All right, so let me move to something interesting. Okay, so it's probably a good idea to start doing some definitions. So the term entity is a general term of art. If I had my way, it would not be a term in BFO at all. There would just be continuant and the current. But for convenience sake, people like to join the continuant part of BFO and the occurrent part of BFO together by having an overarching term called entity at the top. Everything below entity is something which exists in the sense in which all of the things that our Italian colleague at the back is worried about exist. So tax brackets exist. Titles exist. If someone is a professor, then his professorship or her professorship exists. Automobile brands exist. So all of those sociocultural entities which we talk about exist from this perspective. So we don't like reductionism. Unicorns are so far from existing that we can't even say that they don't exist because there's nothing there to talk about. So I won't. All right. Now, but scientific ontologies have to have the following feature, that the developers of the ontology believe that it refers to something on the basis of the best current scientific evidence. And people hate this, and they hated it particularly 5 years ago, before the Higgs boson was shown to exist, because they said if they followed this recipe, then they couldn't have an ontology of Higgs bosons, because people just didn't know whether Higgs bosons existed, but they wanted to do science, and the terminology part of the science that they wanted to do included the term Higgs boson a lot. And so they said, and they printed it, and so it's still there, Barry Smith forbids us to do the science of Higgs boson, which is nonsense. What I said was that if you want to have an ontology, which is a scientific ontology, then you should build it in such a way that every term corresponds to something which you believe to exist on the basis of the best current scientific evidence. Then you can build another ontology, which you could call a speculative ontology, or a tentative ontology, or a hypothetical ontology, and that can have all the Higgs bosons you want, which I did say at the time, but they didn't print that part. I still believe this. I think that scientific ontologies should be based on scientific evidence. And if you're not sure whether Higgs bosons exist, then you shouldn't build an ontology in this sense. You should build an ontology stub or a test thing, but not a scientific ontology. So now I have that on tape, that those people printed that thing. So now all I have to do is get them to watch the tape and feel embarrassed. So for administrative ontologies, matters are quite different. So you can just create a convention. We're going to call all the things listed on Wednesdays, Wednesday things. And that would be a perfectly good administrative ontology. And then they can be dependent on specific tasks and so on, and they can even be secret. So Michael Ashburner, who was the main creator of the gene ontology, was very keen on the idea that there could never be a private ontology, just as there could never be a private science. Science is essentially open, but administrative ontologies are not essentially open. So this is fairly obvious. So scientific ontology is comparable to scientific theories. I think scientific ontologies are the terminological content of scientific theory. Scientific ontologies are a scientific theory as a terminological artifact treated following the rules of ontology construction. That doesn't work for BFO, because BFO is not the terminological content of any scientific theory. It's the equivalent of arithmetic. So arithmetic is perfectly good for doing science, but it's not part of science. And similarly, BFO is perfectly good, we think, for building scientific ontologies, but it's not itself a scientific ontology. All right, now we've seen that. Seen that. And so this is back to granular partitions again. So that is the catalog, that is the inventory. And you need the catalog in order to build a good inventory. And of course the catalog can change. You can have a more granular catalog or a more coarser catalog. You may just have one cell which is the catalog of everything in your factory or everything that you can make with this machine. So scientific ontologies are dealing with types or universals or classes. We've had that. Scientific ontologies are ways of seeing reality through partitions where the cells in the partition are types. And when you write the ontology down on a piece of paper, then the ontology could be here or it could be here. But the important thing is that the ontology is transparent. You see the types through the ontology. And the reason to emphasize this transparency is because Kant and many other philosophers falling in his footsteps, and this is where the world's worst philosophical argument comes in, did not see that our language or the general terms or the categories which we used when experiencing reality were transparent to reality. So, and then what the universals are in reality. So, leg is not the name of a concept, because legs stand to whole bodies in part of relations, and concepts don't stand in part of relations to other concepts. And so we've had that. Okay, now this is an interesting question which we need to get our minds around. So we've talked about this to a certain degree. This is something which people, again, often use an argument against ontological realism. So the ontological realist thinks that the ontology is a representation of types in reality, and that it should be based on our best current scientific evidence about instances of those types, and therefore also about the types themselves. And there are obvious examples, good examples of types or universals which fulfill that criterion without any problems. Things like cells and electrons and quarks are instances of types, and we have good ontologies of the corresponding types. And then we have some terms like leg and centimeter and fever and hypertension and so on, which take those genuinely scientific terms and modify them. They add some kind of Fiat threshold. But we know how to deal with those cases. So we're still within the realm of reality. We're still doing scientific ontology, but we're recognizing that in working with reality, medical scientists or people who do any kind of measurement are creating Fiat thresholds in order to translate a reality which is a continuum into a reality which can be described using discrete units, whether units of measure or units of language. And I think legs and centimeters are more similar than we suppose. They're both products of partition. But then there are terms which are used by scientists which are not the kinds of things which scientists study, or they're not expressed in a scientific way. So this is something which would be used by a scientist, but you would never study that. You would study the person because he's an instance of the type person. He would have the label participant in trial 2030, but he wouldn't be an instance of this type because there is no such type. This is what is called a defined class. And defined classes are, I have to be careful here. Defined classes are created, as it were, by uses of language for scientific or for administrative purposes. But there are no such entities. There are no extra entities in reality which those defined class expressions represent. So let's suppose that you are a participant in trial number 2030. You are an instance, a member of the defined class. But there's nothing about you which makes you an instance of that class rather than your identical twin who is not an instance of that class, which would be analogous to what we know about you when we know that you're a mammal or a male or a possessor of a certain gene mutation. It's just a historical fact about you that you participated in a trial. Like the historical fact that you were baptized at the age of 12. There's nothing about you other than this historical fact, in virtue of which it's true that you were baptized at the age of 12. you are a member of the defined class, people who are baptized at the age of 12, it may be important for the administration of church records in a certain village that you have an administrative ontology in which baptized at the age of 12 is a term. But that would be a term in an administrative ontology which represents a defined class, rather than a term in a scientific ontology which represents a universal in reality. There is no type. Let me see if I... So there is no type. Looks like a fly from a distance. Or is owned by the emperor. Or is what would be another one? Is mentioned in Shakespeare. Or is a type of bird mentioned in Shakespeare. So there was a movement in Australia at one stage to make sure that every type of bird mentioned in Shakespeare would be also a bird which was found naturally in Australia. So they moved all those birds. Now that type of bird mentioned in Shakespeare is a defined class. It's a subclass of birds in general. There is no extra fact about reality in virtue of which some bird is mentioned in Shakespeare. It's a fact about Shakespeare that he mentioned birds. So, defined classes and universals are two different things. Defined classes do not correspond to any extra ingredient in reality. But now there are going to be borderline cases. And abnormal curvature of spine is a very good example, and it's another threshold example. So what counts as abnormal? Where does it become abnormal, and where does it become just a bit curved? So because of this kind of issue, people historically in the last 5 years or so, when BFO was being propagated in various scientific communities, have been skeptical about ontological realism because they say we don't have a real test about whether a given term represents a universal or represents merely a defined class. And so they preferred not to use the word universal, just to talk about classes. And my argument was always the same. We don't have an algorithm for testing whether a given proposition is true or false. That doesn't mean we should just talk about false propositions. Or true propositions are still nice things to have around, and it would be good to keep track of them. And if there are some cases where we can't find out whether a given proposition is true, that doesn't mean we throw out the notion of truth. So that one of my favorite French jokes goes something like this. Even French philosophers have discovered that communism is not true. Therefore, they conclude, there must be something wrong with the notion of truth. Now that's, anyway. So now there are roles. One of the things which Aristotle said is that universals exist in the things that they instantiate. Now, what about the universal fist? Let's suppose that no one at this moment is making a fist. No one, anywhere, on any planet. Does that mean that the universal fist goes out of existence during the time when no one is making a fist? That seems to be unreasonable. So there would be just a few universal terms like fist, crowd. It's hard to think of other good examples. I guess snore. Although snore is an occurrence. Occurrences are different. But it's hard to think of good continuant examples. Now the answer, I believe, is to treat fist not as an extra entity on the side of the hand which makes the fist, but rather as a role. The hand always exists. Sometimes it makes a fist. That means the hand is playing the role of a fist. and then it's not playing the role of the fifth. And now roles are exactly the kinds of things which go into and out of existence. So we don't, and Aristotle would not have wanted to think that there was a fixity of roles. He thought there was a fixity of organism species, so that species could never go into and out of existence, in some places anyway. He talks as if he believes that. But he would never have supposed that roles are marked by the fact that they never go into and out of existence. So roles are going into and out of existence all the time. And so the way to deal with the fifth issue, and the way to deal with these other issues, is to recognize that they're all cases in which roles play a role. So we understand a patient not as a special kind of human being, but as a human being who is playing the role of patient. And we understand an FDA-approved drug not as a special kind of chemical, but a chemical which is playing the role of having been approved by the FDA and being such as to have certain legal roles which follow from having been approved by the FDA. And then accident, so this is a continuum, a current case. So I'm tempted to think of Donald Trump and people who touch one of his minions, whether that was a case of battery or not, but I won't think of that. So if a bus crashes into a car deliberately, it's not an accident. If the bus crashes into the car because the bus driver was distracted or for some similar reason, then it's an accident. Now, physically speaking, there's very little difference between those two. But how the event is treated then, legally and from the point of view of insurance, will be very different. And so what we're dealing with here is not some special kind of collision between two vehicles. We're dealing with a role which a collision between two vehicles plays against the background of legal and insurance treatment consideration. Something like that. Now, just as a matter of passing fascination, so the International Classification of Diseases contains terms like, well, these are accident terms for insurance purposes. Insurance companies wanted to have these terms because they wanted to be able to pay out. A fall on stairs or ladders in water transport injuring occupant of small boat unpowered. Railway accident involving collision with rolling stock and injuring pedal cyclists. And so on. And now we have a real problem. So according to the traditional way of classifying organisms, Homo sapiens is a universal. That traditional way of classifying comes from Linnaeus, who was a follower of Aristotle. Aristotle believed in the fixity of species. He thought that there was a natural organization of species, and that was eternal, and that the place of human beings in that organization was also fixed and eternal. Linnaeus did a better and more detailed job of understanding this hierarchy, but he thought that Homo sapiens was a universal. Now, we know that organisms evolve, and there is a kind of continuum even, if we look at the borders, particularly in areas like bacteria, where organisms evolve along many dimensions very quickly. It's very hard in many cases, and again particularly in bacteria, to work out what the correct Linnaean classification would be. Now, this has led some biologists to develop what they call a population view of species. So according to the Linnaean Aristotelian view, if X is a Homo sapiens, that means X is an instance of the universal Homo sapiens. And so the universal Homo sapiens is part of reality. We could even say that it came into existence when the first human beings evolved, and it will go out of existence when the last human being dies out. But it's a population. And it's the same population. It's just, it started very small and it's been growing more or less ever since. But it's the same population. And that this is shown by the fact that members of it can breed with other contemporaneous members of it. So this is the population view of species. In BFO terms, a species is an object aggregate. And this view that species are individuals rather than universals, with parts, members, rather than instances, has been propounded particularly by David Hull. What's Giselin's first name? Anyway, Giselin, and then Ernst Mayr. And it's sometimes called the population theory of species, it's sometimes called the biological theory of species. One important feature is that the object aggregates in question are distinguished now by fiat. And there is a tendency nowadays on the part of biologists, evolutionary biologists, to want to have more granular divisions of species because they get more resources to protect those species from going extinct. And so you can see the element of fiat is present here. It can only be possible that people can propose that a given collection of organisms be divided into a larger or a smaller number of species if the division in question is a matter of fiat rather than a matter of a discontinuity in nature, what Plato again called a joint of reality. For Aristotle, the distinction between species was a joint in reality. That is why the member of a species A cannot breed successfully with a member of species B, at least for many kinds of organisms, because they are different in nature. Now, I think both views are correct. First of all, I believe that there are fiat universals, and so species can be fiat universals. And the instances of those fiat universals are exactly the members of the populations in the Mayerian view. And I think we need both views. We need both views because we want to have ontologies of those kinds of things which biologists need to talk about, which work well together. And for that, we need to have ontologies of organism types as well as ontologies of things like cell types and protein types. So chemistry is not where the building of ontologies stops. We can have ontologies, we need to have ontologies of organism types, sometimes called taxonomies. And in a way, if I were doing philosophy, I would say that the Maya view is correct. But when we're doing ontology, we know that we're going to need some fiat types. Hypertension is an example. And so there's no ontological price to pay by having also species as being types represented in our ontology. It's just that they are fiat types, like head, tail, leg, and so forth. All right, any questions about that? So that was quite important, that part, yes.
Is there maybe another example other than species of object aggregates which are also generally fiat universals?
So I'm tempted to say the Ford Pinto, but I won't say that. I think the Ford Pinto is actually a better example of a universal than Homo sapiens, because they're more alike. If you just take Ford Pinto 2011 anyway, and you ignore the diesel modification, any artifact which has a production line is going to be a bit similar to this. And of course, the fact that it has a production line is the reason why we want to say that it's a universal, because it has lots of instances. In fact, it has arbitrarily many instances, where if we just have one test model which never goes into production, then it's less tempting to say that we have a universal.
So, and the car will be a fiat universal?
Yeah.
Because we made it?
Yeah.
Okay.
Well, actually, we have to distinguish between universals of fiat entities and fiat universals. So hypertension is a fiat universal because the line between hypertension and non-hypertension is a product of fiat. The universal, which consists of all heads, is I don't even know whether I want to call it the fiat. The heads and hypertension are the same. So let me find another example. Actually, no, I think they are all fiat universals in the same sense. So they're universals whose instances are fiat entities of one sort or another. Threshold entities, entities which exist because of some demarcation, as, for instance, in the case of species. And now, if we think of Ford-Pinto, I am just not sure whether Ford-Pintos are distinguished by fiat. We need to get this clear. So, actually, there is a distinction. Human beings are not fiat entities. We have physical discontinuities. Leaving aside conjoined twins, which are a very, very special case, we have physical discontinuities with all other human beings. So we are bona fide whole objects. However, the universal, which is the species Homo sapiens, is a fiat universal because where it stops and where Nietzschean supermen begin and bonobos end is a matter of fiat. All right? Now, country is a fiat universal in a quite different sense. Each country is itself a fiat object, which exists because people have agreed on a certain boundary. And so there are two kinds of cases. And now the Ford-Pinto certainly does not go in the second case, because Ford-Pintos are just like human beings. They have completely crisp physical discontinuity boundaries in relation to their surroundings. So in what sense is Ford-Pinto a fiat universal? I think not in a very interesting sense, but if I was pushed, I would say, well, let's suppose that in the Ford-Pinto plant in Buffalo, they created a special run of Ford-Pintos with 3 cup holders, but no one liked them. And so Ford refuses to recognize them as real Ford-Pintos. Are they Ford-Pintos at all? Well, that would be a question of fiat, but it's not a very interesting or exciting question. All right. So now let's do, so we have defined classes and we have universals. Defined classes are cases like participant in clinical trial 2030, where we just have an administrative fiat. There are fiat universals, but they're representing their instances are parts of nature which are extra ingredients in being. So there really are countries, there really are regional parts of the organism, there really are cases of hypertension, and there are the hypertension which those cases of hypertension suffer from. So there really are fiat universals, but there are not really defined classes because there is nothing about the world in virtue of which some X is a member of a defined class. But every universal, whether a fiat universal or a bona fide universal, has an extension of all the instances, which is a class. So we have defined classes, and we have those classes which are extensions. Both of them are classes, and the class is just a collection. And so there is the class of Ford-Pintos, there is the class of Homo sapiens, there is the class of people with hypertension, and that's just a collection of all instances. So universals have collections as their extensions. And again, we can define what an extension is. And we note that sometimes we refer to universals by means of an expression, but sometimes we use the same expression to refer to extensions. So HIV is an infectious retrovirus, but also virus, but HIV is spreading very rapidly through Asia. It's the extension of the universal which is spreading. So we need to be careful about that. So we have classes, and we have extensions, and we have defined classes, which are those classes which are not extensions of universals. Now, OWL is very good at dealing with classes. In fact, I think it's really good at dealing with defined classes because it gives us a strategy for defining them. It's not good at all for dealing with universals. And it doesn't care about universals. It's really an ontology which is built for it's an ontology language which is built in its heart, as the Poles say, to deal with administrative ontologies. In order to deal with scientific ontologies, we need to take universals seriously, and OWL does not do that. The reason why we need to take universals seriously is because we need to take scientific laws seriously. And universals are that which is referred to by the general terms in which we formulate scientific laws. Now, populations are examples of defined classes.
Barry, can I ask a question
Yeah.
about that? So, you said earlier that we need to be careful about when we use a general term and it refers to a universal or if it refers to its extension.
Yeah.
But just now you said that scientific truths refer to universals.
Yeah. Scientific laws.
Scientific laws.
So there are scientific truths which refer to instances.
Why not say that the scientific laws always refer to sets of instances instead of universals?
I didn't want to get into another big issue which has to do with when collections exist. But when we're talking about collections of continuants, then those are collections which exist over long periods of time but change their membership. So the Homo sapiens was once a very small collection, now it's a very large collection. It's the same collection, it's just now bigger. Now, set theory won't let you deal with collections which are identical but which have different members, because set theory doesn't have any place for time. Now, when we're dealing with collections of occurrence, that question doesn't arise. When does the collection of all NFL Super Bowl matches, games, Super Bowl, what do you call them? Super Bowls? Anyway, when does that collection exist? Well, there is no answer to that question. When does when does the collection of all Supreme Court hearings exist? The occurrence form collections without their collections being such as to have a history, where continuance form collections where the collection itself has a history. Now you ask your question again and I'll give you the answer.
So the question was, if it's the case that general terms can both apply to universals and to collections of instances, the extension of the universal, then why is it the case that scientific laws always have to be formed around the interpretation of a general noun as a universal rather than as referring to the extension?
Good. All right. So you use the word set in your original formulation. Now, set theory is a branch of mathematics which does not deal with temporal entities. So you can't really use mathematical set theory very neatly to describe collections of the sort that we find, for instance, when dealing with Homo sapiens. I believe that you can't use set theory for those collections generally which are relevant to scientific laws. Now, that's an extreme thesis, so I need to modify it somewhat. When we are doing science, we use set theory quite a bit. We use other parts of mathematics quite a lot. And we can understand those other parts of mathematics also set theoretically. So there is something about science which is very conveniently expressed using the tools of set theory. But those tools of set theory do not give us a representation of anything which exists in reality. They give us a way of building models. mathematical models of what exists in reality, and those mathematical models then can be used in order to carry out reasoning, which then throws light on what exists in reality. Now, we know that what exists in reality includes instances, because we are instances and we exist in reality. The question is, what else exists in reality in virtue of which there are scientific laws? Now, that is the $64,000 question underlying all the work which scientists do. What is science about? I think fundamentally, and I hope this is true, everyone would agree that science is not about arbitrary collections of instances. So it's about those collections of instances which enjoy a sufficient similarity. That's what I mean by universals. So, but it's enjoy the sufficient similarity. That's what makes these two instances of the same universal. It's a structural similarity. Robert Nozick wrote a book called Invariants, which gets quite close, I believe, to capturing the relevant sense of similarity. Talking about universals is a shorthand for talking about families or circles of similars. And then you have to add in the way which is useful for understanding how scientific laws relate to what exists in reality. And now we go back to the Nietzsche issue. Why is science so useful? Because it's true. What is it true of? Well, not arbitrary collections of instances, rather collections of instances which enjoy this structural similarity. And talking about universals is talking about that feature of things in virtue of which they have these structural similarities. That's philosophy, I'm sorry. I guess this is a philosophy class. So you wouldn't notice. All right, so member of ABBA age 50 years or more, that's a defined class. Now we've seen this. So some people say that what we should talk about is not universals in re, that is to say, on the side of reality, but rather concepts in people's heads. Now, I think that is an unfortunate way of talking. I don't think that when you build an ontology, you're building an ontology of concepts. You're using, maybe, your understanding of certain terms to build the ontology, but the ontology represents something in reality. And so I think talk of concepts, which was very popular in the ontology world, but which is increasingly becoming less popular, and that's you can measure that empirically now, that the word concept is used less in ontology circles than it was 10 years ago. So I believe it's an unfortunate distraction. Ontologies are not about concepts. They are about universals and defined classes. One of the reasons why people like to think of ontologies as being about concepts is because then they can save the Higgs boson. Even if there isn't any Higgs boson, they can still have it in their ontology because they still have the concept. And I think that's a mistake, and it's a waste of time talking about it. So I'm going to stop. Now, there are some bad consequences of talking about concepts in that way. If we're allowed to have concepts which correspond to nothing, then we can have terms in our ontology which correspond to nothing because they're about concepts. So these are terms which you find in ontologies, even some very prestigious government-funded ontologies. So congenital absent nipple is a nipple, a special kind of nipple, namely one that is not there. And now they talk about negative allergies, which is the absence of analogy. And this is spawn of the lazy concept terminology. All right, then we can define an ontology, and then we come to the end. I really did go through this phase. So I discovered new ways of making things move. All right, so any questions? Yes.
Now we see a little bit more about partitions.
Yeah.
When we define say we have universal, and we can define partitions, right?
Yeah.
But there are also relations among the partitions.
Ah, yes, good.
So, can I say that this new partition, based on the previous one, would be a second order partition, something like this?
Yes, so actually I did address this point very briefly. You remember I had the pictures of the cow, and we partitioned the cow into cuts. And then we have the partition of quality and age. So the cut is a product of the partition of the cow. The quality can be applied to every single cut. So you can take a tenderloin, which is of top quality, A triple prime, and which is young. So there we have the relation to time, we have the relation of quality, and we have the relation of origin in the cow. So that there we have three partitions, and we put the three partitions together and we have a catalog. And there are some, if you go to Google, you'll get gigantic screenshots of all the different cuts and with different ages, how they look and so forth. Different marbling. So marbling is the quality, and then age since slaughter is the time dimension. So those relations can be captured using BFO, and they do indeed create what you might think of as being, I would think of them as being three-dimensional partitions. One dimension is the cut, one dimension is the quality, and one dimension is the age. And we can have multi-dimensional partitions. So if that's what you meant, then we agree. And you can only have the quality and the age if you have the cut. So you can't measure age unless you have a cut. But you can have a cut without measuring the age. But you should probably eat it quickly then. Yep.
So how do you treat phases like the one of the absent nipple, congenital absent nipple?
So there is a real positive genetic mutation in virtue of which this particular patient is missing a nipple. So this particular patient doesn't have a special kind of nipple, they have a special kind of genetic mutation. Also, and this is also an area where concept language leads sometimes to confusion, there is the observation that there is no nipple. And the reason why people started talking about negative allergies is because people made the observation that there was no allergy. And so they had to find a code for there is no allergy observation. And so they called that, stupidly, negative allergy, which is exactly the wrong thing to call it. What you should call it is, we looked for an allergy and failed to find one. Or we looked for an allergy to such and such and we failed to find one. So this is an ontology of observations, not an ontology of observed entities. And in medical ontology of a certain sort, not a good sort, for a long time people confused the ontology of observations with the ontology of things observed. And so the particular brand of medical ontology still exists. It goes by the name of HL7. And I remember, so HL7 was supposed to be based on speech act theory. And I remember a paper, early HL7 paper on the basic codes of HL7, in which they said these codes are based on speech act theory of J.L. Austin and John Searle. And as speech act theory proved, there is never a distinction between a document and reality. That's what they said. Now, what they were trying to say in their, I don't want to get angry here, in their way, was when you're in a hospital, it doesn't matter whether there was a nipple or whether there was a cut or a wound or bleeding what matters is what gets written down in the document. But no speech act theory, none of the traditional speech act theorists anyway, would ever say that there is no reality outside the document. French philosophers may say, but
Well, maybe there's an adjacent problem,
yes.
which is the problem of saying what false statements are about.
So that's the paper that Werner Koisters and I wrote about aboutness. And basically, false statements are always about something in parts. President Obama is the president of Russia, is about President Obama, the role of being president, and Russia. But it's not, the sentence as a whole is not about him.
How do you represent that in an L file?
That's your job.
Great.
Yep.
I think I missed this lecture, but what about fiction that's not about anything?
Give me your best example of aboutless fiction.
Star Trek? I don't think any of that's real.
So it seems to be a lot about pieces of equipment, metal vehicles, space, vaguely anthropomorphized
Euclid's geometry.
creatures. Yeah, it's about lots of things.
What's that?
It's about love and
Euclid's
death
geometry.
and violence and empires and.
Euclid's geometry is not about anything.
So you said Euclidean geometry. I didn't go down that
No,
way.
I was just posing that next.
So it's about space. We all agree with that.
Is it?
Yeah, of
Is
course
it
it is.
about perfect,
Stars and
perfect things
stars.
that never attain?
I've never actually watched Star Trek, so how would I know? But
No,
it's
now I'm talking. Okay, Star Trek aside. Now you. So what's that about?
what's it?
Euclid's elements. What's that about?
That's a very good question. So actually, that particular document is easy to deal with because it's about things like drawing lines,
Yeah.
drawing other lines, and then measuring the angles and things. So that's pretty easy. If you ask me what an axiomatization of Euclidean geometry is about, I wouldn't have a good answer ready, but I never made any claims about axiomatic theories being about anything.
Sure. So when we were talking, so my question was, what about dealing with? Maybe I misled by saying fiction, but said about propositions or sentences or something that don't seem to be about anything.
For instance,
purely like axioms and geometry.
yeah, I confess that I don't have a quick answer to that.
That's
And
all.
it's an interesting one. We should ask Werner what he thinks. So I could do it with Higgs boson, but assuming that there was no Higgs boson, every sentence about Higgs boson would be about something else also, and then the Higgs boson part would just be, it wouldn't have its little yellow arrow sticking out of its back. Because just as maps have arrows sticking out of their backs, pointing to points on the surface of the reality, so sentences have arrows coming out of them. You can see them if I turn. Any more? Yes?
Can I press this point one more time? So let's say that not Obama is president of Russia, because we have Obama and he's a proper noun and
Yeah.
it picks him out. But if we said Jeff Smith is president of Russia, but
Yeah.
there is no Jeff Smith,
Yeah.
is that statement about, it can't be about a man who is president of Russia, because there is no instance of a man. So it has to be about...
I think you're going to get the aboutness to a human being, not necessarily a man, from president, because every occupant of the president role has to be a human being. Indeed, a human being aged over 35 and so forth.
right? Is
So
in-
you get man for free, or human being.
so Jeff Smith is in Russia. All we get is physical objects in Russia.
So even just Russia is good enough for that. Even just in is already sort of about something. It's not a big claim. And I could probably get somewhere with in and betweenness for geometry too. So what is geometry about? Incidence and betweenness.
Hilbert.
All right? Any more? Okay, so we'll meet again in a week's time.